And just so you know, our experience, we're going to work on optimization problem. So, just a quick thing, we're talking about optimization problem, and any optimization problem has these three components. So we're first going to figure out where my decision variables are, and there might be one or more, but most likely there will be more than one decision variable. So you have to first pick up what are the decision variables. Then you have to figure out what is the objective function. Right? So objective function is the function that you are trying to maximize or minimize, and decision variables are the variables that you're trying to visualize. Your variables are visualized. And then there's going to be a constraints. Some of the constraints will be posed by the question, and some of the constraints will be physics constraints, meaning that something cannot be negative or something can be integer. Physics constraints and some constraints posed by the question. All right. So we talked about where we thought optimization. We first take the model and model, and then we go to working it on solving it. So we talked about these first two steps last time. So today we're going to talk about step 3, 4, and 5. So the problem that we are going to tackle is called that problem. And the reason I just tackle problem is because it's a problem in the book. So if you're not getting something to solve. So we are in the process of making all of the business. This manufacturer has decided to move into market of medium and high price products. And however many bags they can make, their distributor have agreed to buy on from the country. Now, to make a bag, they have to go through this few operations. Cutting and design, sewing, finishing, and inspection. Now, of course, they don't have unlimited amount of time in each of the departments. So they have limited amount of time. For example, the entire department has 3 hours, the sewing department has 600 hours, the department has 8 hours, and inspection packaging has 100 hours. These are the total available hours in each. Now, what you see is that the required hours to make each standard bag needs 7 by 10 hours, the cutting and dyeing department, half an hour, sewing department, 1 hour, station department, and 1 by 10 hours. Same happens for the rest of the bag and most of the numbers that they require for each department requires to make 1 bag. So these are targets. Now, if they can make this bag, they can sell it. So if they sell a standard bag, they make $10 per bag as a profit. And if they make a business bag, they sell a business bag, they will make $90 per business profit. That's what we care about. It has profit for money that they're making. So the problem that we were looking at is that they want to determine the number of standard bags and number of deluxe bags made so that their profit is back. So they want to figure out how many deluxe bags to make and how many standard bags to make such that their total profit is back. So what is going to be a decision variable? What is the management trying to decide? Or how many decision variables do we have? How many standard bags to prepare or make? How many deluxe bags to make? We have 2 decision variables. These are the 2 numbers that we want to figure. What is my objective function? Total profit is the objective function, and you are maximizing your objective. And what are your constraints? Can you make as many bags as you want? No, right? So what are the constraints? Yes. So each department has a resource availability, and that's your constraint. So you cannot use up more than what you have. So we learned how to develop the model. That's that. So quickly go to the model 1, and then we will move on. So the first thing you need to do is you would name the decision variable. So we call that S call the number of standard packs to produce, D call the number of deluxe packs to produce, and then you're gonna write down your. So you're maximizing profit. So the way you write down the one is maximizing profit. This is your total profit because you're making $10 per standard bag and $9 per deluxe bag. You're making N standard bags and D deluxe bags. Based on unit algebra, this is your total profit. And then similarly, you're going to calculate the constraints, which each constraint is going to tell you that the amount of time you're spending in each department is less than equals to what it is. For example, the first constraint tells you the total amount of time in cutting and dyeing department, that's the left, and that number has to be less than equals to what's available to 6. And how does this equation come up? So 7 times an hour you need in cutting and dyeing department for one standard bag. So you need 7 multiplied by S for making S standard bags. And 1 hour you need cutting and dyeing department for one deluxe bag. So you need 1 multiplied by B for making B. So you just do a couple of unit algebra and then the sum of it is the total amount of time that you need to spend in cutting and dyeing department to make S standard bags and D. That number has to be less than equals to 630 because that's what's available in cutting and dyeing. You cannot use up more than what you can call it constraint. And then we have some physics constraints, meaning that you cannot do the physical things, you cannot reduce negative numbers. So that's why you know that your S, the number of standard bags, has to be greater than equals to 0. And D, the number of deluxe bags has to be the model. If you learn your class 100 because we went over this. So validating the model is really just writing down the model and then putting on the mesh, right? Does it explain everything, or does it contain everything that the problem has said? All the components of the problem has given us. Does this model contain? It's basically just to take all the components. Now we're gonna solve the model. So there are 2 solution approaches, and we are not gonna go into method 1. So we're gonna jump into method, and you're never gonna use method 1 because method 1 is a graphical method, and it's only useful for when you're solving problem with 2. But in reality, we will have more than 2 graphical methods. So I will go over it next class just to give you an idea what happened in different. But today, just let's focus on how to solve this. So, here. In your car, there's a car Excel file. So what I'm giving you is giving me put it. So what I'm giving you is all the inputs and the parameters. So these are all the numbers that's coming from your question. So these are called the parameters of the model. And the main difference of our visualization and simulation and the approximation problems, I'm going to give you these parameters exact numbers. But when we move on to simulation, these parameters are going to be random numbers. Derived from a probability. So that's going to be the main. But yeah, for explanation, I'm going to give you. So what this number means, basically here you see give you all the operational production times, right? So for example, the cutting and dyeing department so needs 0.7 hours to make one standard bag and 1 hour to make one deluxe bag. They have 630 hours. Similarly, savings department has 0.5 hours to make a standard bag and 0.823 hours to make a deluxe bag, and they have 600 hours. So I've just input all the data, and then there is a profit. So for if you sell a standard bag, it's you're gonna make $10 in profit. If you're gonna sell a deluxe bag, then you're gonna make $5. Any question about the input parameters? Understand what's there? So let's move on right now our model. So what is the first thing we need to write down? So what is the first component that I need to figure out? No, decision variable. So first thing we're gonna write down is my decision variable. I'm gonna write down decision variables. So you can make decision variables in your head, or you can just say standard and deluxe. So I'm just gonna use S and D, but you can say standard and deluxe. You can use any name. We have two decision variables. One is number of standard bags produced, the other one number of deluxe bags. Then I'm making S. Now, under S and D, these are going to be the value of the decision variable. Now, you can start with any value. Doesn't matter what value you start with, once we run the model, all of us are gonna get the same numbers. That's the solution. So I generally like to start with some zeros and ones. Why? Because if I do that, then when I'm writing down my constraints and objective function, I can verify in my head if it's doing the right number. Then you're welcome to use any number. But I'm gonna start with some zeros and I invite you to do the similar zeros and ones so that you can even calculate in your head when I'm writing down other ones. Alright. What's the next thing? I need to write down. What's the next part? Objective functions. Right now. So what is my objective function? Problem. Right from the top. In these writings, I'm going to really make the model more understandable. The writing is more systematic. The thing that you need to do is to write the correct form. So under total profit, now I'm going to write down the formula of total profit using the parameters and decision. That's what I'm going to do. So what is my total profit? It's going to be 10 multiplied by S plus 9 multiplied by B. Because you're making a standard bag and B deluxe bags, you're making $10 per standard bag and $9 per B. So because I did zeros and ones, I know in my head that this number should be, what should be this number? 9, right? So that's the forms of doing zeros and ones, so you know you calculate. So this is my so far so good. So we're going to solve it because code is going to line. It cannot go to just cannot. Next one. What's next? So for constraints, we're just going to write down our main constraints, and then the non-negative constraints, you don't need to write it down because I'm going to show you how in Excel you can tell that arguments were not. These are my constraints, right? So all the constraints are going to look like time required, and a be less than equals to time. So what's going to be my time required for function type? Again, I'm going to do the same thing, right? So this is to make one standard bank. So I'm going to multiply that by any decision variable. So remember to click always the numbers and not the letters. So if you click the letter S, the letter D, you're not creating your function. So you have to create the numbers under your decision variable A. Plus this multiplied by. So this is how you're calculating the total time between cutting and dicing. This is exactly what we did in our problem. 0.7 multiplied by S plus 100. Less than equals to. So what should be this number? 6. Multiplied by X plus S multiplied by T. And then for finishing, we're going to leave this. I'm going to show the form, all of the problems. Plus 0.67 multiplied by 2. Less than equals to 708. And then similarly for inspection and packaging, 70 multiplied by X plus this. This is less. This is the video. This is a little bit conversion to two, right? Every time. And so one of the functions in Excel is if you were calculating non-zero would like the distance from time. But we could also use a simple function in Excel that will help us use the constant. So some problem is a very useful function that we're going to use a lot for optimization. Because you see, you know this how this formula is. So this formula is created by doing product of two cells and then summing them. So all of them are created that way. They're doing products of two cells and summing them. So the function that we can use is called sum product. So we're going to do the product first, and then sum. So how the sum product function works is, let's say you have here, C15. C2 is A multiplied by C plus So what's that? So we can use some product function to really make these formulas right. So for example, instead of writing total profit this way, we could use some product. And then we'll put average in the page. Right, because it's average in the total profit. So you're gonna take the profit average and secondary is gonna be so what I want. Secondary is gonna be a decision tree. So this is something that is gonna always be the same way, that whenever you're writing the sum product function for your objective function or for your constraints, one of the arrays are going to be your decision variable. And the other array is going to be whatever you're doing. Let's say your objective function is another array is your profit array. For your constraints, the other array is gonna be whatever constraints you're doing. And if you do that, you're gonna get the signal. Comma. And that's gonna do B19 multiplied by B40 plus C19 multiplied by C40. Okay. So we can use either one by one if we can comfortable that way, or we can use some other function. If we do that, it's gonna give you this. So you could also do, let's change one of this. Can you tell me how can I do some product for this one? Some product. What's gonna be my array one? It doesn't matter which array is first, right? So you can put the singular array first and then the other array. A5 and C5, comma. So that's gonna calculate your total target pattern. So if I want to change my formula such that I can extract it out, what else I need? Which cells are constant in all of your formulas? The decision first. B14, C14 are constant. B14, C14 are always multiplying with that. So I can just dollar this B14. And then I can save. Keep writing if you feel confidently, just picking and sticking and then writing the formula in a more standard form. That's fine. You could also use some kind of function to do it fast. Any questions with the model system?
And you're just utilizing the sign, say that it needs to be left A without time allotted.
Any questions on the model so far? So if not, we're gonna try to solve the problem. Ready to solve? Everyone got it? The model? Okay. So to solve, now we need a different addition. Okay? We're gonna use the solver adding to solve it. Now, just like you got your analysis toolpath, you're gonna go and get your solver. The same. Wherever you found your analysis toolpath, you're gonna also find the solver. So for me, it's gonna be more options. Then right here, that's solver. You're gonna click on solver already. So under data now, you will see solver. So does everyone see solver under the complete panel? So everyone has solver? So let's pull up solver. Let's click on solver. So just like in regression, we just need to fill out the whole box. The first thing it's asking is set objective. So first thing we're gonna do is set objective, which means that Excel wants you to give you the link, the cell where you have written the objective function. Go ahead and link the cell where you have calculated your objective function, the number and the formula, not where you have written objective function or fill the problem. You're gonna click on the cell where you've written the formula. So either click here or click here, wherever you've written. Wherever you have calculated your objective function. Everything you're gonna click wherever you have calculated, your numbers are showing, not that. Right. Then it's asking you, are you maximizing this? Are you minimizing? Max. Right? So you have to make sure that you click on max for maximizing problems and click on min for minimizing. So first of all, next is asking by changing variable cells. What is this? Decision variables. These are your decision variables. So here you are going to place wherever you are putting your decision variables. So right here, you're gonna click wherever you have connected your decision variables. So the numbers again, not a letter. I got it from your other. That's something I'm very proud of. That's the function of the and decision variable. Decision variable that you are going to change. So what Excel is going to do is Excel is going to change these variables using an algorithm and then try to optimize or maximize your objective. Now you're going to add your constraint. So right here, you're going to write add. And you can do either all of them together or one by one. So first I do one by one because you have to do one by one if your signs are different. And if you have the same sign for all the constraints, you can drag all of them. So in this case, I have the same sign for all the constraints, so I could drag all of them together. And I'm going to do one by one because it might be the case that there are different constraints or different signs. So first, you're going to select your left hand side, then you're going to select the sign, and then you're going to select your right. You're going to add one more constraint, left hand side, less than equals to. One more constraint, left hand side, less than equals to. The last constraint, left hand side, less than. When you finish selecting all of them, or adding all of them, when you click OK, all of your constraints are going to show up. Any questions? You could also actually select all of them together. Way to do that would be select all of the left hand sides. And when all of the left hand sides are less than or equals to, then let's select all. So these three constraints, these four constraints together, it's saying the same thing as this. So you can delete either those four, or I'm just going to delete. You can click on it. You don't have this four or just the one. So the next thing you need to tell Excel that I want non-negative solution, because I don't want that my S and D to be negative. Do that, you're just going to click like it says that make unconstrained variables non-negative. So all of your decision variables are going to be non-negative. Click there, it's already taken care of the new decision variable. Right as a branch. And then the final thing is solving that. So we are going to use something called syntax LB for all of your linear programs, all of your linear operations. And next class I'm going to tell you a little bit about what syntax means and why this is very efficient and that. But today just trust me and click on syntax. And that's it. If you are ready with this, go ahead and press off. And you will see a pop-up box will emerge. If you press off, you will see keep solver solution. Yes, you want to keep solver solution. So click on that. So you'll see the values of everything has changed. S and D, they're not 0 and 1 anymore. There's some numbers. And those are your optimal numbers. Those are what you saw. All of us should get the same number. Whatever we started with, even if we started with 1 million, 1 million, 1, we should come back to the same. So the way to maximize profit is to make 540 standard bags and 252 deluxe bags. And that will make 7,698. That's the maximum profit. Okay, so let me go and troubleshoot. Anyone else? You ready to do the extra work? Okay. Small problem. The cake problem. And also I have the small original here for you. So you can use that right in your exam. So basically the problem you're looking at is you see the cake baking problem in cake baking extra credit. You see that, right? Now let's do what this problem is coming out with like comment. Problem you're making chocolate cakes and vanilla cakes, and you're trying to figure out how many chocolate cakes to bake and how many vanilla cakes to bake, so that your total profit is there. So one chocolate cake, the selling price is $20, and vanilla cake selling price is $15. And let's say you are not, you don't have any, you're not costing any money to bake. You're just getting it for free from your family. So you have total for 50 minutes available and 56 eggs in the fridge. And each chocolate cake takes 40 minutes to bake, and each vanilla cake takes 20 minutes to bake. And each chocolate cake needs 3 eggs to bake, and each vanilla cake needs 2 eggs. So you're trying to figure out what is the number of chocolate cakes to bake, and what is the number of vanilla cakes. We have how many decision variables? 2, right? So this is why your decision variables you can write it like this. My computer doesn't want me to help you though. So you're gonna start with naming your decision variable, and then start with any number as it is. Doesn't matter what number it is. So with any number you want, I will suggest you start with zeros and ones, just because then gonna do the whole it is. Vector function is to group. You can calculate either using some sort of function or using the product method. Okay, some sort of function. This is the last. Then you just gonna do some products and prices. Or it could also be 20 multiplied by 0 plus 3. You have two constraints, time and egg, and you're going to do it. points for this one. Just because you guys are. Alright, these numbers gonna give you a fraction. That's fine. Because we're not adding the integer constraint in, so. So what to add integer constraint, what you can do, we can add one more, but you don't have to quit it. You can go ahead and add an integer constraint. So what you can do is when you add your constraint, then you can add the decision variables and you can say, and then add it, and then if you do that, you're gonna get an integer. Again, I'm only looking for if you understood how to model it. So the regular action number is fine. Okay. And then if you could just show me. If you just submit, if you will have a that integer constraint that you're gonna get for relative. That's showing that we're straight. Maybe it's not even the we're not making any chocolate cakes, even though it's more profitable.
There's nothing.
The reason why